Welcome back. Today, we're diving into a topic that I know can feel a bit intimidating, but it's actually one of the most powerful tools in algebra, factorization. So let's forget the boring textbook drills, okay? We're going to treat this like we're cracking a secret code.
So take a look at this expression. It looks like one solid thing, right? But what if I told you it's actually built from simpler pieces, kind of like a cake has hidden ingredients? The real question is, can we find them? Well, that's the puzzle we're going to solve together today.
So what is factorization really? At its heart, it's just finding those fundamental building blocks. Think of it this way. You know that 2 times 3 is 6. Well, factorization is just starting with the 6 and figuring out, hey, this came from a 2 and a 3. It's just reverse multiplication, and it is the absolute key to simplifying and solving all sorts of algebra problems. To really master this, we're going to build a complete factorization toolkit, piece by piece. We'll start with finding a common factor, then move on to grouping, learn how to spot some special patterns, and finally, we'll crack those tricky trinomials. By the end of this, you're going to have a full set of tools to tackle almost any expression.
All right, let's grab our very first tool. This is the one you should always reach for first. It's the simplest and, often the most powerful method there is, just finding the common factor.
Let's look at this expression, 5x squared minus 10x. Our goal here is to find the single biggest piece that fits into both of those terms. So what number divides both 5 and 10? Yep, it's 5. And what variable is in both terms? Well, that's x. So our greatest common factor is 5x.
So here's the play-by-play in 3 steps. Step 1, we just look at it and find our biggest common piece, which we decided was 5x. Step 2, we divide each of the original terms by it. So 5x squared divided by 5x, that leaves us with just x. And negative 10x divided by 5x, that leaves us with negative 2. Step 3, you take that common factor, the 5x, stick it outside some brackets, and put whatever's left over on the inside. And just like that, boom, you get 5x times x minus 2. Simple as that.
Okay, but what happens when there isn't one single factor that's common to all the terms? Do we just give up? No way. We just need a new tool. So let's up our game and move to the next one, factorization by grouping.
Check this one out. ax minus bx plus ay minus by. See, there's no single number or letter that's in all 4 terms. But if you look a little closer, the first 2 terms share an x, and the last 2 share a y. By creating these little groups, we can find common factors inside of them. It's a classic divide-and-conquer strategy, really.
So the process is what's crucial here. First, we group the terms, right? So we've got ax minus bx and ay minus by. Then we factorize each little group on its own. That gives us x times a minus b and y times a minus b. And now, look what happened. A new common factor just appeared. The whole bracket, a minus b, is now common to both parts. So we pull that out front, and what are we left with? Our final factors, a minus b times x plus y. Now we're getting into the really cool stuff. Once you get good at the basics, you start seeing these patterns everywhere. And recognizing these special patterns, it's like having a secret shortcut. It's a total pro move that'll save you a ton of time.
And the first major pattern you should always be on the lookout for is this one. It sounds a little formal, I know, the difference of 2 squares, but the idea behind it is super simple and incredibly powerful.
Take a look at this example. 25a squared minus 36b squared. You see the pattern? 25a squared is really just 5a all squared. And 36b squared? That's just 6b all squared. So what we really have is one squared thing minus another squared thing. That's the pattern. That is the difference of 2 squares.
And whenever you see that pattern, this golden rule applies every single time. It always factors into 2 brackets, the first thing plus the second times the first thing minus the second. So for our example, it just becomes 5a plus 6b times 5a minus 6b. Seriously, once you see this pattern, you can't unsee it.
Okay, let's add another pattern to our mental library. This one is for expressions that have 3 terms, what we call trinomials. It's called the perfect square trinomial.
These are the 2 formulas you need to burn into your brain. And notice the structure, right? You've got a squared term at the beginning, a squared term at the end, and that middle term is twice the product of their square roots. If the middle term is positive, it all squishes down to a plus b squared. If it's negative, it becomes a minus b squared.
So how do we actually use this? Let's test it on this example. The first term, 4x squared, that's just 2x squared.
The last term, 9y squared, is 3y squared. Okay, now for the big test. Is that middle term, 12xy, equal to 2 times our a and b? Well, let's see. 2 times 2x times 3y is 12xy. It is. It's a perfect match. So this whole long expression simplifies down beautifully to just 2x plus 3y squared.
All right, we've handled the basics, we've handled the special patterns. Now it's time for the final boss, the method that works on pretty much any trinomial, even when it's not a perfect square. This is the ultimate tool in our kit, splitting the middle term.
Now don't let the name intimidate you. This is just another puzzle. The whole game is about finding two magic numbers. For instance, if we need two numbers that multiply to 6 and add up to 5, what are they? It's got to be 2 and 3, right? That's it. That simple little skill is the entire heart of factorizing these trinomials. Let's see this thing in action. We need to factorize x squared minus 9x plus 20. So we're on the hunt for two numbers that multiply to give us 20 and add up to give us that middle number, -9. After a little thought, you land on -5 and -4. They multiply to a +20, and they add to a -9. Perfect.
So how do we put it all together? The process is actually pretty straightforward. Once we find our magic numbers, in this case -5 and -4, we use them to literally split that middle term. The -9x becomes -5x minus 4x, and all of a sudden we have a 4-term expression. Now this is where it all connects. You just use our grouping tool from before, you factor by grouping, and you get your answer, x minus 5 times x minus 4. It's a brilliant method because it pulls together our earlier skills perfectly.
And there you have it. We've worked through all the methods, from the most basic to the most advanced. So congratulations, you've just built yourself a complete, really powerful toolkit for factorization. So let's just recap what's in your new toolkit. You've got the essential first step of taking out common factors. You've got the strategic move of factorization by grouping. You have the shortcuts for spotting the difference of two squares and perfect square trinomials. And of course, you have the master key, splitting the middle term. You are ready to go. You know, in the end, it all comes back to this one simple definition. We're not doing magic here. We're just finding the original pieces that were multiplied together to make the expression we started with. We're just deconstructing to understand. So I'll leave you with this final thought. We've spent this time learning how to break things down into their basic components. And this skill, it's crucial for solving equations, simplifying really complex problems, and just truly getting the structure of math. So the real question is, now that you have all the tools you need to deconstruct, what new understanding will you build?